Welcome. I'm Carl Tate. The topic is, what is the time scale for Earth history? Here's a list of some events relevant to geology, seismology in Alaska, starting way back. Galaxy formation, 13 billion years ago. Earth forms, 4.6 billion years ago. Life begins, plate tectonics. This is extracted from one of the Alaska earthquake science facts videos. What we start with over here, though, is just some abbreviations. Capital M means millions, K means thousands. So when we see MA, it refers to millions of years ago, KA thousands of years ago. So when we see something about 12 KA, 12,000 years ago, that would be about 10,000 BCE, years before the Common Era. You'll also see this MYR, million years, or kilo years. These are the same. So we need to have a sense of thousands and millions of years to discuss things like plate tectonics. How Alaska got to what it is today is a story that is millions of years old. So we need to understand and think about those timescales that we may not be familiar with. But we are familiar with things like dinosaurs, 230 million years ago, mammals, early man, Homo sapiens, right up into history. Human migration to Alaska 12,000 years ago, Russian settlement in Kodiak 1784, coming up to the instrumental era in seismology, 1904, for example. But what is the timescale for Earth's history? That's told in the story of rocks. And this quite colorful picture is the geological timescale going from oldest at the lower right to all the way up in today. And we'll zoom in on this to look at some of the details. What you see, the oldest rocks on Earth are 4.3 billion years old, or 4,300 million years old. That's starting the time scale on Earth. We'll zoom in onto the most recent part, because for much of this class, when we talk about earthquakes and we talk about active plate tectonics, we're talking about things that are happening right now today and things that have happened in the last few million years, which is still considered active if you're looking at this chart. So here's the Cenozoic, that upper left, and we can read this a little better. We see the MA, millions of years time frame on the left, and so it's going from 10 million years ago to today. One thing that's kind of interesting, the time scale itself is calibrated using magnetic polarity data from rocks at the seafloor, and we'll get into that shortly. But you see that the importance of magnetic information on defining time right here on the time scale, showing this banding here is actually the polarity of the magnetic field during that time period. So active volcanoes, for example, are identified if they erupted within the Holocene epoch. So that is the last 12,000 years. So we have plots showing active volcanoes. You want to be thinking, well, active, 12,000 years is considered pretty active in geological time. The Quaternary Period covers the past 2.5 million years. It's made up of the Holocene and Pleistocene. You may have heard some of these terms in terms of ice age discussion, especially for research going on in Alaska. A lot of things can be frozen for a long period of time. Current plate motions, for example, in this plate velocity model, refers to motion averaged over the past 3 million years. So again, we have to get our brains thinking, what is meant by current or active? Geologically speaking, 3 million years is nothing when you consider the Earth is 4,600 million years old, but it's not exactly things that are happening necessarily right now. Takeaway topics. Earthquakes are relevant on human timescales of years, decades, and centuries. Earthquakes have occurred on Earth for millions of years, as long as we have had plate tectonics, which will be discussed soon. The Earth is 4.6 billion years old.